Hello and welcome to the next rendition of Chapter 6. We're going to be playing with some more radicals. We're going to be adding, we're going to be subtracting, we're going to be multiplying. It's going to be fun. This is 6.3. Alright, here we go. We're in 6.3 and we're going to start with adding and subtracting radicals. So if you can try to get into the mindset of adding and subtracting variables, then this will be not terrible for you because it's the same concept. So basically first when you got a simple all radicals. So that means like if we see a 27 or a 12, we need to see if those radicals will simplify it all to see if they can be combined. So then you're going to identify radicals with the same index and the same radicand. So that means that this number and this number have to be the exact same for you to be able to combine like terms. So then only these can be combined. So then after that, you're just going to combine like terms. But the catch here is, again, you have to have the same index and same radicand. Again, this number has to be the exact same. This number has to be the exact same. Other than that, you're just adding and subtracting coefficients, and you can treat the radicals like variables. They have to match exactly the same, and when they do, you're just going to add and subtract. So let's see what that looks like. So step one, you got to look at your radicals and you have to simplify them. And I know some of you hate this part, but this is why we practice this so much, so that we can actually start doing math with it. So I'm just going to look at this one right there, and I'm going to simplify that. So I've gotten good enough to this point to where I know that 27 is 9 times 3. And we're doing just normal square roots. And I know that the square root of 9 is going to be 3. So my square root of 27 is also the same as 3 times square root of 3. So if that doesn't make sense to you, we got to back up a little bit and we got to practice that skill a little bit more. So over here on the 12, so again, I've gotten good enough to know that 4 times 3 is 12, so square root of 12 is the same as square root of 4 times square root of 3, which is the same as 2 square root of 3. Okay, so I'm going to move this stuff a little bit. And so now we can simplify. First we're going to simplify all of our radicals, and then we can actually do the math. So what we've got now is we've got 3, that's from that one, times 3, that's from that one, square root of 3 minus, 2, that's from that guy, times 2 from that guy, square root of 3. Okay, so I'm going to start with simplifying these things, and then hopefully you notice that these are the same as well, so they're going to get combined later on. So we've got 9 square root of 3 minus 4 square root of 3. And like I said, when the radicals are the exact same, treat it like a variable. So this would be like 9x minus 4x. So we would know that that's just going to be 5x. But in this case, it's going to be 5 square root of 3. So we're still doing algebra. We're using those algebra techniques. But now our x's are just going to look like radical signs. So number 3 is an example of a curveball that might get thrown at you. When you look at it carefully, you might notice that there's fourth roots right there and then a third root right there. So those are never going to combine. So that third root is just going to be by itself no matter what. But as our last process, we're just going to simplify everything. And then from there, we can start doing our algebra. So if I'm looking at the fourth root of 48, I definitely don't know that off the top of my head. So 48, I of course needed my calculator. So 48 divided by 2 is 2 times 24. 24 divided by 2 is 2 times 12. 2 times 6. 2 times 3. We're dealing with fourth roots, so that means I need 4. 1, 2, 3, 4. So that's going to simplify. I'm just going to bring this whole thing down and say 7 times 2 is going to come out. 4th root of 3 left over. Minus, okay, so now we're going to do this guy. I'll do it in blue. Hey, look, it's simplified. That one was really easy. Nothing can come out of 3, and I know that those things are the same, so that's a good indication. And last but not least, that's 72. I probably need to do that 72. So 72 divided by 2, 2 times 36. 36 divided by 2, 2 times 18, 2 times 9, 3 times 3. It's a cubed root, so I need 3 of them to come out. And so that means that I have 3 times 2. The 3 came from there. 2 came from there. 3 times 2, cubed root of, what do we have left over? 9. So that might look weird having a 9 under that root, but remember, it's a cubed root, not a squared root. So anyway, now we've got a 4th root of 3, a 4th root of 3. We can combine these like terms. This is just going to stay as is, but we'll simplify this, and away we go. So our final answer is going to be 7 times 2 is 14 minus another 2. So that's going to be 12. 4th root of 3 plus 6 cubed root of 9. So again, I'm hoping that you're making the connection that once you get these square roots simplified, they just turn into variables. The ones that match can be combined, added, or subtracted. The ones that don't match have to stay separate. This same process is going to work when we start throwing in variables. So hopefully it doesn't throw you too much for a loop, but here we go. So number 5, I'm going to do some of my scratch work over here. So 98, yeah, I don't know. So, poof. And with the magic of technology, I'm done. So it's a square root. I found a 7 and a 7, so that 7 is going to come out. And then that 2 is going to stay inside. And then when we look at our variables, remember, we're doing square roots. So that's also the same as writing it like x to the 4 over 2 times y to the 2 over 2. So I'm going to use that fractional thing. You don't necessarily have to write that out, but that's kind of where my head's at. And that's how I think about bringing those variables outside of the square root. But anyway, so when we take this 98, we're going to have 7 on the outside, square root. Oh, I need to move that. Inside the square root, we're going to have a 2 left over. That comes from this 2 and this 7 that's going to come out. So then we've got x to the 4 over 2. That is the same as x squared. 4 divided by 2 is 2. And then y to the 2 over 2, which is just like y to the 1th, which is just y. So there we have our first term. Our second term is conveniently already simplified. So we have 3x squared y root 2. So now the question is, are we going to combine them? And the answer is yes, but it's also yes because each and every variable matches. If even one of those things was different, we would not combine them. They have to be exactly the same. So we're going to start combining them. So it's just 7 times this big fat variable minus 3 times this the same big fat variable. So we're going to do 7 minus 3, which is 4. Sure. 4x squared y root 2. And that is your final answer. So now we're going to start multiplying. So remember, adding and subtracting is different than multiplying, right? So in this case, we're going to multiply the coefficients and then use the product rule. So the product rule says that if these two are the same, then we just multiply A and B. So for example, so they gave us kind of the rule there with our variables. So that's going to be equal to n square root of A times B. So basically, if the square root or if the radicals are the same, then you're just going to multiply everything underneath. So we look at this one right here. We could simplify it first, or we could multiply it first and then simplify. It actually doesn't matter. And so what I mean by simplify, so hopefully you recognize that this is 9 times 3. 9 is a perfect root. You can pull the 3 out if you want. Or you can just go all the way through. 27 times 5. So that's going to be equal to square root of 135. And now that I think about it, I think it would have been easier to simplify this first. But hey, whatever. Because we multiplied by 27, I know that a 9 comes out. So I'm just going to take 135 divided by 9. And we're going to get 15, which is not a perfect square. So when the 9 comes out of the square root, we're going to have 3. So I'll write that out. So we've got 9 times the square root of 15, which then equals 3 square root of 15. So I feel like multiplying is a little bit easier, but you have to really work hard to keep adding and subtracting and multiplying different in your head. Okay, so this time I'm just going to simplify first because I think that it's going to be easier that way. I don't know that for sure, but so I'm looking at number 9. This does not simplify. Remember, it is a cubed root. 9 is a perfect square root, but not going to be a cubed root, at least not yet. So, but 24, I just did it in my calculator. 24, you got 2 times 12, 2 times 6, 2 times 3. You got 3 of those 2's. So I'm going to rewrite this as 2 cube root of 9 times, that 2 is going to come out, times 10 cube root of negative 3. So yes, there's a negative sign under the cube root. That is fine because it's a cube root, not a square root. So now from there, we're going to multiply the coefficients. Then we're going to multiply the underneath the radical sign, and we're going to see what we get. So we'll have 20 cubed root of 9 times 3 is negative 27, right? Yeah. So now, and this is where my brain's at, 9 is 3 times 3 times another 3. That's 3 3's. Okay, so 27 is 3 times 3 times 3, which means that 3, it is a perfect cube. So that 3 can come out. So our final answer is going to be 20 times a negative 3, which is negative 60. So final answer, negative 60. Okay, let's throw some variables in there and see what happens. So we're going to follow the same process. I can't simplify either of these just yet. They're both square roots. I could actually pull the variables out, but doesn't matter. So we're just going to multiply everything underneath the square root first, and then we'll start simplifying from there. So our coefficients, this is an implied 1 times 5. So we're going to have a 5 on the outside, square root 6 times 8. 6 times 8 is 48. I knew that. And then x to the 4th times x to the 5th. We're going to add those exponents. So that's going to be x to the 9th. And now we're going to simplify that. So 48 looks like we can pull a 16 out of that. 48 divided by 16. 16 is the square root of 16 is 4. So we're going to divide all that out. Square root of 16 times square root of 3 times, and remember we're going to do like kind of x to the 9 over 2th power. I'm just doing that in my head. And so anyway, we're going to have 5 times 4, square root of 3. We're going to have, how many times does 2 go into 9? Goes in 4 times. So we're going to have x to the 4th on the outside, and then we're going to have 1x remaining on the inside. So this is not our final answer. Our final answer, we got to simplify the 5 and the 2, or the 4. So 5 times 4, so we're going to have 20 x to the 4th square root of 3x. So this is our final answer. All right, let's look at a cubed root, give you a good example here. So we're looking at 2 cubed roots multiplied together. And again, because they're the same cubed root, we're just going to multiply everything on the inside. So we've got, 3 times 6, which I totally know off the top of my head. 3 times 36, sorry. So then we're going to have a negative 108. So we do have a negative sign. It's not that big of a deal because it's a cubed root, not a squared root. So we're going to have negative 108. And then a to the 7 times a to the 6. We're just going to add those exponents. So it's going to be a 12, 13. And then b to the 4th times b to the 2nd. We're going to add those exponents too. So it's going to be 4, 5, 6. So we're going to have b to the 6. And this is all cubed root. So here I'm going to look at, we'll start with the number first. So my number 108, I'm sure that is divisible, or there's probably a perfect cube in there or somewhere. I don't know what it is off the top of my head. So I'm going to do my little factor tree. So 2 times 54, 54 divided by 2. 2 times 27, that should have been a 27. And then 27 is 3 times 3 times 3. So there's actually my perfect root. So this is going to come out, this is going to stay in. Remember, because we're in a cubed root, you need 3 matching numbers. So I'm just going to go ahead and pull my 3 out, and then I'm going to have 2 times 2 left over. So that's going to be cubed root negative 4. We can pull the negative sign out too. We're going to do that. So we've got 4 on the inside. And then for our variables, so again, I'm kind of thinking in my head that little fractional thing that we do. So if I have a to the 13th over 3, so that's going to be, how many times does 3 go into 13? So 4 times 3 is 12, right? So 13 over 3 is 4 with 1 remainder, or a remainder of 1/3. So that means that my a to the 4th, and it actually goes right there. So we're going to move this over. So I'm going to pull out an a to the 4th, and we're going to have 1a left over inside of the parenthesis. So then we're going to do the same thing with the b. So it's b 6 over 3. 6 over 3 is actually just 2. So then we're going to have b squared that comes out. So that's an example of doing a cubed root. So this is your answer. Okay, what happens if we have binomials? So what's kind of nice about this is if you're good at the algebra side of things, then it's all the same process right now. So if we were to just look at this as a variable, different variable, different variable, how would we solve that? So we would distribute this number into the parentheses. So that's what we're going to do. So we're going to do square root of 10 times that, square root of 10 times that, and we will be in business. So we're going to follow all the same rules. Square root of 10, it's under a square root. So those square roots, we're going to multiply everything under the square roots. So that means we're going to have 5 square root of 50 minus square root of 10 times 2 square root of 2. It's going to be 2 square root of 20. So then we're going to reduce those as much as possible. When we do that, we're going to get 5 square root of 25 times square root of 2. 2 square root of 4 square square root of 5. So those are all multiplied together. And so then we're going to take care of this guy. We're going to take care of this guy. And now we're going to have 5 times 5 times square root of 2 minus 2 times 2 times square root of 5, which means our final answer is 25 square root of 2 minus 4 square root of 5. So in these problems, it's really important to actually reduce these radical signs as much as possible, because on the off chance that these final ones actually do match, then you can combine. If they don't match, then I guess it's not as big of a deal, but a lot of times they will match and you'll be able to combine those like terms. So this will be my last problem, number 17, just to show you another version of these problems. So again, we've got these two more different variables. Just treat it like we normally would. So in this case, we are going to FOIL, or whatever you want to call it. But we'll do the purple, the first step. So our under the square roots, we're going to multiply together. So that's going to be 6 times square root of 36, which is actually 6 as well. So then plus 6 square root of 12. And then this guy goes over there. We'll do that in blue. So minus 6 square root of 2 times square root of 6. So that's going to be 6 square root of 12. Again, note that we're just multiplying everything under the square root. 6 root 2 times root 2 again. That's going to be 6 root 4. And so then we can simplify these things. This is going to be 6 times 6 plus 12. We can pull a 4 out, right? Oh no, just kidding. So check this out. We've got a positive 6 root 12. We got a negative 6 root 12. So those are just going to get canceled out. That's convenient. And then this guy, we're going to do minus 6 root 4. Root 4 is the same as 2. So that's going to be minus 6 times 2. It means we're going to have 36 minus 12, which means it is going to be 24. See, isn't that a nice, happy answer for such a complicated problem? But again, the trick here is, number one, you multiply everything under the square root or the matching radical sign. And then other than that, treat it like a variable, and we're just doing more algebra, right? So we'll do some more examples in class, and I'll see you there.